Good morning. It's March 5th, and this is your daily brief in science. Here's everything you need to know. A new Nature study says global assessments of sea level rise may be underestimating coastal risk by about 0.2 to 0.3 meters, with potential increases in vulnerable regions like Southeast Asia and the Indo-Pacific reaching over 1 meter. The misestimation comes from simplified geoid models that ignore tides, currents, salinity-driven density differences, regional subsidence, and regional gravitational and rotational variations, creating regional baseline discrepancies. If sea level rises a little over 3 feet by the century's end, corrected baselines could mean up to 37% more land inundation, threatening 77 million to 132 million more people, and complicating planning and funding for climate impact responses. Independent researchers say the findings highlight underestimation of risks, but caution that not all future projection scenarios would be altered. Policymakers are urged to ensure coastal risk data are locally validated and aligned to guide resource allocation and action. The article notes the Nature publication and discusses verification challenges related to access to the full article. Only a minority of reviewed studies properly integrated data, with just one meeting full data documentation and correct integration, underscoring a broad methodological gap. Some scientists warn the implications may be overstated for planners, while others see room for methodological improvements and broader recognition of regional differences. Experts outside the study caution that risk increases could complicate adaptation funding, though some acknowledge the issue is not uniform across regions. Critics outside the study note that in some regions, local planners possess better region-specific elevation data and planning practices. The refinement could improve coastal hazard reports and support more effective adaptation or relocation decisions if needed. While the study does not provide a Portugal-specific analysis, vulnerable zones like the Costa da Caparica, the Tagus Estuary, Figueira da Foz, and parts of the Algarve could face earlier and greater risks, prompting revisions to municipal plans and investments. A landmark step for advanced nuclear. The U.S. Nuclear Regulatory Commission has granted TerraPower the first construction permit in 8 years for a commercial reactor, allowing work to begin on the Natrium plant in western Wyoming with an online target around 2030. TerraPower first filed in 2024 and started site prep that year, marking the NRC's first construction permit for a non-light water commercial reactor in more than 4 decades. The Natrium project is the first commercial-scale advanced reactor to receive this permit, a milestone that underscores a shift in how the sector views new designs. Natrium uses liquid sodium cooling rather than traditional water, a design choice intended to reduce shielding and safety costs. It is a fast neutron reactor that could consume certain radioactive isotopes that would otherwise become waste in conventional reactors. The plant is designed to deliver up to 500 megawatts of electricity, with flexibility to generate or store energy for grid support. Critics point to safety risks and long-term waste disposal concerns, weighing potential environmental benefits against drawbacks. Policy and supply questions loom, including limited enriched uranium availability and ongoing federal discussions on spent fuel management and possible reprocessing partnerships. TerraPower argues the design aims for shorter construction times and lower costs compared with traditional reactors, aided by integrated energy storage to enable flexible ramping. The project reflects a broader strategy to combine compact power output, energy storage, and renewable integration in advanced reactor designs, while facing challenges such as potential cost overruns and fuel supply concerns that could affect schedule and budget. A new call to action on GLP-1 receptor therapies puts weight maintenance under the microscope as researchers urge more trials into body composition during and after treatment and demand clear diet and exercise guidance for sustaining gains after stopping. Current guidelines are inconsistent, with NICE setting a 2-year limit for semaglutide, but not for tirzepatide, raising questions about how post-treatment weight regain is addressed. The study emphasizes understanding how body composition changes during therapy and after cessation, and notes that many guidelines fail to tackle the issue of weight regain once GLP-1 RAS end. Common side effects, including nausea, headaches, and diarrhea, affect about 1 in 10 users. and there are rare but serious pancreatitis reports among Wegovy users at low frequencies. Evidence also points to appetite suppression during treatment that can lead to rebound weight gain when the therapy is stopped. A BMJ study of U.S. veterans found starting GLP-1 injections is linked to a reduced risk of substance use disorders and related healthcare events, with larger benefits for those with prior SUDS, and benefits appeared in both sexes in a cohort dominated by older men. The medications work by mimicking hormonal signals and have effects that last days, unlike natural hormones which break down quickly. Yet many users discontinue early due to G1 side effects, cost, insurance coverage limits, and access barriers, with roughly half of initiators stopping therapy. About half of participants initiating GLP-1 weight loss therapy discontinue prematurely because of side effects, cost, and insurance or prescribing barriers, undermining long-term weight loss. Experts note that roughly half of patients discontinue early due to G1 side effects, cost, and insurance or prescribing barriers, limiting long-term effectiveness. Long-term data are lacking, and real-world long-term outcomes beyond theoretical projections remain unsettled. A promising gene therapy for Dravet syndrome is shaping up as a potential shift from symptom control to targeting the genetic cause. In a United States-United Kingdom trial, 81 children and adolescents aged 2 to 18 received different doses of zorevunersen, with seizure reductions from 59% to 91% over about 20 months. Early results also show improvements in daily functioning and quality of life, with many participants reporting gains over a multi-year period and mostly mild side effects. The therapy targets the SCN1A gene, aiming to address core symptoms rather than just managing them. Phase 3 trials are now underway to confirm efficacy and safety and to pave the way for broader clinical adoption. The findings, published in the New England Journal of Medicine, reinforce evidence that zorevunersen can address motor, behavioral, and cognitive aspects of the condition. Supporters, including Dravet Syndrome United Kingdom, emphasize the potential for near-normal lives if treatment scales and continues to optimize. Current treatments often fail to achieve seizure freedom and do not adequately address long-term impairments associated with Dravet syndrome. Experts describe this as a potential shift toward treating the genetic root, with implications for other monogenic epilepsies. International epilepsy researchers welcomed the study as a meaningful advance in therapies for hard-to-treat genetic epilepsies, while independent experts and patient advocates call the results incredibly promising and potentially life-changing for families. Optimism remains that improved outcomes could substantially alter long-term prognosis and quality of life for patients, with leading clinicians calling the results promising and potentially life-changing for families dealing with Dravet syndrome. A new DNA foundation model called EVO2, developed by ARC Institute and NVIDIA, is published in Nature and trained on DNA from over 100,000 species to identify disease-causing mutations, and even design genomes up to the length of simple bacterial genomes. The project emphasizes openness, with data, training, and inference code, and model weights publicly available on GITHUB and integrated with NVIDIA-BIONEMO, aiming to generalize across life for applications like targeted gene regulation and genome design. Open science is central. EVO2, its training and inference code, and the OPENGENOME2 dataset are fully open to accelerate exploration and design of biological complexity. Regulatory DNA design showed modest success, with 17% activity differences across 2 cell types, while fully functional, novel proteins remain unproven and not yet on par with design-grade protein engineering. On regulatory tasks, EVO2 embeddings outperform other unsupervised DNA models, but sequence-to-function models trained with task-specific data still excel for certain regulatory predictions. The STRIPEDHYENA2 architecture blends input-dependent convolution with attention to enable efficient long-range sequence modeling and higher throughput than transformer baselines at large context lengths. EVO2 embeddings can train supervised classifiers for tasks like BRCA1 variant interpretation, achieving high AUROC and AUPRC when leveraging layer-specific features. Variant effect prediction is competitive in zero-shot coding, SNVS, and superior for non-SNV coding and non-coding variants, with strong BRCA1 and BRCA2 analyses versus specialized models. EV02 can predict some regulatory features and certain structural protein aspects, but designing fully functional proteins or highly active, organism-specific regulatory DNA in eukaryotes remains limited. The article notes ongoing questions about discovering novel genome features and whether EV02 will yield innovative biological insights beyond known features like intron-exon boundaries and regulatory motifs. Overall, EV02 marks a significant step in AI-assisted genome analysis and annotation, with potential for research and biotechnological design, while noting current limitations in designing novel, functional sequences. Mechanistic interpretability shows EV02 learns latent representations of biological features such as exon-intron structure and mobile elements, prophages, CRISPR spacers, via sparse autoencoders and contrastive searches. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.